This lecture is going to be based on McKinney's Chapter 42, The Child with an Immunologic Alteration. Really, much of the information that you'll find in the beginning of this chapter, which is what I'm going to cover in this lecture, is very similar to what you'll find in Iggy's text, but gives a little bit more detail on some areas and is a little bit more top-heavy. So in other words, doesn't dig as deep in some areas as well. So it's a good alternative read if Iggy is giving you grief or if you just want a little bit more information. So the immune system, we can also call it the lymphoreticular system. It's an internal defense system with secondary and tertiary protection. The non-specific and specific responses, as we've talked about in lecture, the non-specific responses really refer to the inflammation process, whereas specific responses are more geared toward the antibody-mediated, and cellular-mediated immune is kind of in the middle between there. There are some specific and some non-specific aspects of cellular-mediated immunity. Antigens are any foreign protein that is in the body that is seen as non-self. These are anything from bacteria, fungus, to another human cell. Proteins that are called antibodies or immunoglobulins are produced against those antigens, and each antibody is specific to an antigen. As we've talked about in class as well, antigens and antibodies combine together to create complexes, antigen-antibody complexes, and this can either lead to agglutination, which is a big clumping of antigen and antibodies, or it can lead to something as simple as the antigen not being allowed to bind to susceptible organs or tissues. Talking again about those non-specific immune functions, we have a list here of non-specific immune functions, including things like chemical barriers. That would be like our normal flora on our skin. The inflammatory response is non-specific, as I said. And what happens is we see the increased capillary permeability because of the inflammation response and the vasodilation, which leads to phagocytosis and elimination of those toxins that have been introduced into the body. Let's look really quickly at the childhood immune system. You can see that on this page, this is actually also a figure in your McKinney book. In Chapter 42, this gives a good indication of what we see in the childhood immune system and what it actually means. I have a little bit more information that I'm going to talk about the maturity of the immune system, but otherwise what we have here on this figure is pretty self-explanatory. The bone marrow contains the stem cells that those pluripotent stem cells that make the lymphocytes and the leukocytes. Peyer's patches are right there near the appendix and in the GI system, and they act as filters to remove debris and antigen entering the GI tract. The lymph nodes are, you can see those throughout the body, act as filters as well. Tonsils and adenoids act as filters. You can see the thymus right there where the sternum would be, and that is where the cells that mature into T lymphocytes go for maturation. The spleen is a filter type organ, and then more lymph nodes are listed over there on the other side. So that's going clockwise, starting at about 7 o'clock with bone marrow. Let's talk a little bit about specific immune function as far as maturation and as far as childhood development. In the first year of life, lymphocytes make up greater than 50% of all white blood cells because they rapidly develop immune function at that age. So in that first year of life, kids are developing their immune system at a huge rate. So 50%, more than 50% of white blood cells are lymphocytes as they're developing their immune system. And then after that first year, they drop off to 25 to 30% of white blood cells. Lymphocytes, like we know, are divided into B and T cells. B cells, which is that humoral response, or the antibody-mediated response, are using those antigens to make antibodies. So the B cells make the antibodies. In the humoral response, the macrophage and the T cell help the B cell respond to that antigen, and then the B cell makes the antibodies and eventually differentiates into plasma cells and memory cells. So the plasma cells, remember, are what release antibodies, and the memory cells are what remember that antigen in the future. In our cell-mediated response, a lot of what we see there are T cells or helper T cells. T cells have their maturation in the thymus. The macrophages present the antigen to a T cell, and then the T cell facilitates the destruction of the antigen by calling in other white blood cells. They call them to arms. They bring them in to work against that antigen. Cytotoxic T cells are also important in the cell-mediated response, and they kill pathogens like viruses and tumor cells directly, and then they also use their chemicals that they exude to either sustain or end the immune response. So fetuses have begun B cell differentiation by 8 weeks gestation. So that's in utero. At 8 weeks gestation, B cells are starting to differentiate against certain antigens. By 24 weeks of gestation, a normal fetus is already producing IgM, so the immunoglobulin M, which are those first antibodies produced. If we're looking at IgM versus IgG, as far as antenatal periods go, IgG is the prenatal transfer of maternal antibodies. IgA is the transfer of antibodies in breast milk. And IgM is what the fetus produces itself. Active immunity, as we've known, is the longest lasting immunity and can last an entire lifetime. It comes from the body reacting specifically to an antigen and creating either an antibody or a cell-mediated response. So this would be actual exposure to an antigen would be active natural active immunity.